This video we're going to discuss perpendicular bisectors and how they are affected in triangles when you create three of them, the relationship that they have, also perpendicular bisectors of a segment and what they do. So we're going to start with some constructions with this segment, constructing the perpendicular bisector of the line segment. Remember, to do this, you open the compass more than halfway, less than the whole way, and from one point you swing around. You go to the other point with the same opening, swing around. Your goal is to get the compass arcs to cross above and below the line. You're going to connect the intersections of the arcs together to create your perpendicular bisector of the segment. The goal of this particular station, which we're just kind of doing stations for each thing today, is to find out the relationship of points along this line. Follow the instructions below to see the relationship between points on this line and the perpendicular bisector. I'm not going to tell you what it is in this video because I want you to kind of discover that, and then you can look at the key to see the summary of their relationship. Hopefully you paused, completed the sheet up to this point. I'm going to show you how to do the constructions on the triangle now. So constructing the perpendicular bisector for each side of the triangle. So we're going to do this 3 times, 1 time for each side. Remember, you need to open your compass more than halfway, less than the whole way. And then you might need to put some paper underneath depending on the opening of your compass and how close your triangle is to the edge of your paper. So go from one end of the segment and the other end. Oh, good, it was on the paper. That's awesome. So we've got our 2 intersections. This is going to be our perpendicular bisector number 1. Then we go to another side and do the perpendicular bisector of this side. So going from one corner, going from the other corner. Now these are going to get really crazy looking because there's so many arcs. It's going to get kind of messy. Just expect that. And don't erase your arcs because that's how we grade. So you want to put your right angle and you want to mark your segments congruent. And I should have done that in the first one. Knowing that as a perpendicular bisector, it splits a segment and makes a right angle, splits a segment and makes a right angle. I'm going to do the third one. If you do this really well, you will find that they are all going to cross at the same point. Now, of course, you know, we're human, we make mistakes. We're not always going to be perfect. They may not meet at the exact same spot, but as long as they're within reason, you're going to get full credit. Again, don't erase your arcs. You can see it's getting super messy. Finding where they cross sometimes is hard because so much is going on. Here's my 2 intersections. And your goal is to hit where those other 2 crossed. That's really special. So we're going to connect these. I think I'm doing pretty good. I can see where they are crossing. And you want to draw your perpendicular bisector all the way through the triangle so you can find that crossing. Don't just make it like a partial one. And then I'm going to do a 3 mark and a 3 mark because I've already used a 1 and a 2 and now I have a 3. So you can see with these perpendicular bisectors, they do a lot of things. They split the segment in half. They make right angles. Notice how it doesn't go through the vertex necessarily. It will sometimes and sometimes not. That's one way to tell you have a perpendicular bisector, is that it doesn't necessarily have to hit the vertex. We're going to talk about a lot of other segments today, and most of them have to hit the vertex, but this one does not, so it's a key feature for perpendicular bisectors. You can see my 3 bisectors are meeting at this point. That's very special that these 3 lines that we constructed do meet at a single point. That point is called a point of concurrency, and each point of concurrency we're talking about between today and tomorrow has a special name. The point of concurrency of the perpendicular bisectors is called the circumcenter. What's special about this point is that it is equidistant from each of the vertices of the triangle. You could measure them, and of course we constructed, so within reason, they should be about the same distance from each of the vertices. If you do a really good job, you can even use this point and open your compass to the vertice, and you can construct, using the compass, a circle that will go all around your triangle, where the vertices of the triangle are all on the edge of the circle. Oh yay, it just barely fit on the paper there. There we go. You can see the circle that surrounds the figure. So what's cool about that is that we could draw radii of the circle from the point of concurrency, that circumcenter, to each vertex of the triangle. You're going to have different types of problems with the perpendicular bisector. Some of them will involve the fact that these radii are congruent. Some of them will involve the fact that the segments on the sides are bisected. Some of them will even involve Pythagorean theorem. They might draw in these yellow lines that we have, and the piece of the perpendicular bisector and the piece of the side. See that forms a right triangle. And they might label those pieces, and then you might have to use Pythagorean theorem to do some solving. So those are the main ideas for the perpendicular bisectors. So try to fill this in from what we just discussed, and see the key for this so that you can get the summary of the concept as well.